Okay, so we're going to start talking about how to solve linear equations. So this is just a step-by-step guide to help us walking through solving linear equations. This is not necessarily going to be applying to everything else, but just really to linear equations for now. So first thing we want to do is we want to definitely simplify both sides of the equation. So when we simplify it, we get down to pretty much it may be just a variable with a coefficient. It could just be a number on one side. It could be one side is a variable with coefficient and a number. The other side's the same. There's a variety of ways they'll simplify, but you're simplifying down as much as you can on both sides. Then if once we simplify, we need to go on to this next step. We will use the additive inverse and the addition property of equality to isolate a constant to one side and then your x term to the other side. So not always just x term, but really just your variable term. Because it could be y instead, but really like that variable term. We're going to use division and multiplication to just isolate that x by itself. So just to remove the coefficient on it. Then always, this is a step we tend to ignore, you always want to check your solutions. We will check our solutions a few times, and then we're just going to keep going. Okay, so what we mean by simplify both sides is we're going to take this side here, and we see that, well, I have like terms here. I have an x to the fourth, and I have a minus x to the sixth. That is a negative 2x. There's nothing like with that 7, so then we just keep the 7. We have 10 and 12 are like terms here. So we got 10 plus 12. We add that together. We get 22 plus 3x. So that is simplified down. Then we're going to basically isolate your variable term to one side. We're going to use those addition properties that we had. So here we're going to have that negative 2x plus 7 equals 22 plus 3x. Then what I'm going to do is, oops, let me go back a little bit. What I can do is we can move this term with an x and move it to one side, or you can move these terms, whichever you want to do first. So I'm going to pick, because this is already negative, I'm going to add 2x here to get rid of that negative 2x. And what I do to one side, I have to do to the other. So we get this. So these cancel. I'm just left with my 7 here. I still keep my 22 plus 3x plus 2x, which is 5x. All right, so we're still trying to isolate that variable term, this 5x now. The way I can do that is I got this 22 here. Well, the additive inverse of that is a negative 22, which I have to do negative 22 from the other side. So 7 minus negative 22. If you weren't sure about that, you can always stick that in your calculator. That's negative 15. So step 3 is we are going to isolate the variable. We're going to isolate that x. We're not talking about the term, just the variable itself. So this is where we're going to use multiplication or division to do this. So what I can do is that I have this 5 here and I don't want it there. I'll divide by 5 here and I'll divide by 5 here. And if I do that, I get negative 3x. Or if you want to, you can rewrite that as x equals negative 3. And then, like I said, this is the step that we tend to forget about. If you're doing this by hand, well, even if you do this as a calculator, there's always a chance you made a mistake. So we want to make sure, does x actually equal negative 3? So we're going to plug it back into the original equation. So we had 4x plus 7 minus 6x equals 10 plus 3x plus 12. So now we have 4 times minus 3 plus 7 minus 6 times negative 3 equals 10 plus 3 times negative 3 plus 12. 4 times negative 3, that's negative 12. Negative 6 times negative 3 plus 18. 3 times negative 3 will be negative 9. And now we just have to simplify by addition here. So if I start adding this down, we are going to have, let's see, negative 12 plus 7 plus 18 is 13. And then on the other side, we have 10 minus 9 plus 12, which is also 13. So both sides are the same. Then we know x really does equal negative 3. We got it right. This is a little more complicated because we got a little bit more simplifying to do. It's not just like terms. So first we have to distribute. We're going to do that simplification first. Make it a different place to see that a little better. So we're going to have to do these distributions first to simplify. So in this case, we're going to do step 1. We're going to simplify. So first we're going to do 3 minus 8 times x, 8x, negative 8 times 6. Oops, some messed up here. Sorry, 8 times 6 is, sorry, negative 8 times 6 is 48. Make sure I say that right. 4 times x is 4x. X times negative 1 is 4 minus 5. So we did the distribution. Now we combine like terms. So here we have 4x minus 9, doing the easy side first. Here we got minus 8x. So we have 3 minus 48, so that'd be negative 45. So step 2, we want to get our x's to one side. So like I said, I don't have to do the x's first. I can do these constants first. So I could add 9 to both sides if I wanted to. And it's going to take me down to this step, so negative 8x. Make sure I don't make any mistakes here. There we go. Minus 36 is equal to 4x, because that's gone. Now well, my x is on one side, so I have to move this one because there's nothing I can do about this one. All I do is move it to the other side and I have two things there. So I'm going to add 8x. We get negative 36 is going to be equal to 12x. So step 3 is we just went to isolate that x. So in this case, x is divided by 12, so we are multiplied by 12, so we divide both sides by 12. And we get a negative 3 equals x again. So remember, we always want to check. So 3 minus 8, and I said x is negative 3, so I want negative 3 plus 6. Then I have 4 times x, which is negative 3, minus 1, close parentheses, minus 5. So 3 minus 8 times 3 now, 4 times minus 4 minus 5. 3, I can't do 8 times 3 for some reason today. Negative 8 times 3 is 24. We get negative 16 minus 5 here. So 3 minus 24 is negative 21. Negative 16 minus 5 is also negative 21. Checks out. We got the right answer. Like I said, we're just doing the checking to make sure we did it correctly. So these are just some extra techniques that we have. So sometimes we will have decimals for our coefficients and our constants. We need to be able to rectify that. But we have a way to try to make this a little easier so it's back to something we're familiar with. So that is very common with math. The way we like to solve problems is we have an easy way that we first learn. Then things get more complicated. Take that complicated part and try to make it look like the easy part. And that's what we're going to do here. So when we try to solve a linear equation with decimal constants or and or coefficients, we can multiply each side of the equation by multiples of 10. So we'll see what we're going to do there, which will provide us with an equivalent equation without decimals. The multiple of 10 we use is dependent on the constant and coefficient with the most decimals. So the number of decimals will equal the number of zeros after the 1. So what I mean by that is that, let's say I had 0.2x equals 0.41x minus 5. So this has the most decimals in it. So what I'd do is I'd multiply both sides by 1, and this is 2 decimal places, so I'd multiply by 100. So that's what we mean by that. If I multiply both sides by 100, so 100 times 0.2 is going to give me 20x. 100 times 0. I forgot my x here, sorry. Let's fix that. So 100 times 0.41x is going to leave me with 41x. And then 100 times 5 is going to be 500. So what we're doing is we're just trying to, like I said, work this into something that we're familiar with. This is something we've seen before. This is something that we could easily solve. So very quickly, this is very similar. So 2.3 equals 6.1x minus 3.11. 3.11 has the most decimals, has 2, so we multiply by 100. So I can change this into, by multiplying everything by 100, is 230. Yeah, that's right. I thought that was wrong for a second. 230 equals 610x minus 311. All right, and that was the type of there. Now we have equivalent equations, no decimal. We have a similar thing for fractions as well, how to deal with fractions. So for example, we have this question here. So we have a decimal, we have 1 decimal place here. We have 1 decimal place here. We have 2 here. So because we're going to multiply by 100. If I had 3 decimal places, I'd multiply by 1,000. If everything was just 1 decimal place, I'd multiply by 10. So like I said, just find the one with the most. So take each side of the equation and we multiply it by 100 because we're trying to get rid of those decimals. So if you're not very comfortable with your decimals, you can always stick this into a calculator and you'll see it. But really what it's doing is I have to go back 2 decimal places. So if my decimal is here, it moves back to here. Same thing. If I move this decimal place 2 places back, that's going to leave me with 120y. If I move this one 2 places back, this is going to leave me with 724 after I multiply by those 100s. Okay. So now we just have to isolate that variable that we have, our y. Let me get my calculator here. 724 minus 1,840 is going to leave me with minus 1,100. Oh, sorry, 1,116. There we go. And here we'll be just left with the negative 620y. Divide both sides by negative 620. 1116 divided by 620. And that's going to give me a 1.8. When you probably don't want to check by hand. you might just want to stick this on your calculator, this side, and then see if you're going to get 724. So 18.4 minus 6.2 times 1.8 is, in fact, 700.24. Yay, it checks out. This is my answer. So as I said, sometimes we have fractions we need to deal with. So we are given an equation such as 2x minus 3 divided by 6 is equal to 58 plus 3 divided by 8. So we're looking for your LCD. This is called your lowest, or no, least common. Sorry, I'm getting confused with the other version of this. Least common denominator divisor. So what we're really looking for is we're trying to find the smallest number that both 6 and 8 divide into. The smallest number both 6 and 8 divide into. You can also cheat and you can just take these two numbers and multiply them together and it'll also work as well. So if we multiply both sides by 24, we have 24 divided by 6, which is 3. If I have 24 here, I have 24 divided by 8, which is going to leave me with 4. So what's going to happen here is that we keep this, we got rid of our denominators is what we did. We made them disappear. So now we just have 3 times 2x minus 6, 3. It's a typo there. And we have 4 times 5x plus 3. So this is, once again, something that's much easier for us to solve. So there's a lot of variation on clearing the fractions. We're trying to make it a little easier for us. So this one, I only have one number that I have to worry about, and that's this 5. Because this one only has a divisor of 1, really. So we're going to multiply by 5. So that's both sides. So that means we have 3 times y plus 3 divided by 5. We're going to take all that and we want to multiply it by 5. We also have 2y plus 6, and I want to take all of that and I want to multiply it by 5. What I do to one side, I do to the other. So here, this 5 and this 5 cancel, and I'm just left with my 3, y plus 3. Well, I can't cancel this one out because there's nothing to cancel with. So on this side, I just have 5 times 2y plus 6. So once again, we got something that's easy for us to handle. So if I keep on going, if I distribute my 3's, I have 3y plus 9. Here I have 10y plus 30. If I subtract 3y from both sides, I'm going to have 9 equals 7y plus 30. And then if I subtract 30 from both sides, I am going to have negative 21 equals 7y. So if I divide both sides by 7, I get y equals negative 3. And it was not intentional that so many of these things are y equals negative 3. Wasn't going to check, and then I realized, no, we have to do this one. This one's weird. So just to show you this, because every time we have zeros appear, a lot of people think it kind of throws us off a little bit. So this, if I replace all my y's with negative 3, that's 3 times negative 3 plus 3 over 5 equals 2 times negative 3 plus 6. So we have 3 times 0 over 5 here, and here we have negative 6 equals times 6. Either way, we're going to see both sides equal 0. Here, this is perfectly okay when we're checking equations. Remember, we're checking solution. So try not to let this confuse you when you get into something which is finding infinite solutions. In this case, I'm checking solutions and it's 0 and 0 on both sides. This means that we found the correct solution. All right, so I'm going to let you try this on your own and then come back, but just kind of quickly go through this. So an equation solving procedure, we like to clear fractions or decimals if that is needed. It may not always be needed, but if it is, that's the first thing we want to do. After that, if we have parentheses occur, we want to multiply and remove them using the distributive law. Then, once those are taken care of or they're not a problem, then the thing we want to look for next is collecting like terms. So on each side, you're going to simplify by collecting like terms. Then after you get your simplifying, so 2 and 3 are basically simplifying altogether. 4, you're going to use the addition principle to move anything that basically put like terms together. So anything with a variable ends up on one side, everything's a constant is the other side. So we may have to collect, like I said, collect like terms on each side again if necessary. Sometimes you just have to do that again once you move things around. It shouldn't happen too often. And then we want to use the multiplication principle to solve the variable. So that's if we have like 3x is equal to 21, we want to make sure we divide both sides by 3. We're just trying to isolate that x. So this should set worksheet, but this is still part of your problems. So you should have these problems A, B, C, D, E, F. So take a couple minutes or however you need, try attempt all these and then come back and we'll work through these problems. Okay, so starting with A. So we have 2x plus 6 equals 20. This is a pretty easy one. All we really do need to do, we don't have any decimals to worry about. We don't have any fractions to worry about. We don't have to simplify both sides. That's already there for us. We just have to get x's, or we need the x term by itself and we need the constants by themselves. So if I just subtract 6 from both sides, I am just going to have 2x is equal to 14. Then divide both sides by 2, I get x is equal to 7. I just double check that quick. 2 times 7 plus 6. So 2 times 7 is 14 plus 6. 14 plus 6 is 20. It checks out. We have a solution. All right, this one requires a little bit more work because now we need to we need just a little bit more work. We don't have to simplify like on A, but we do have a little bit of moving around to try to isolate x terms to one side and constants to the other. Like I said, it doesn't really matter which one we start with first. So let's do the add 18. So we get a constant by each constants by themselves. So that means we're left with 7x here. Here we'll have negative 3x plus 20. Well, now I have to add that 3x to both sides. So I can cancel out this negative 3. And we have 20 is equal to 10x. If you really don't like it being this way, you can just flip it. So you have 10x is equal to 20. So if I divide both sides by 10, we are going to get x is equal to 2. Now I'll just double check that we did this right. So negative 3 times 2 plus 2 equals 7 times 2 minus 18. We will have negative 6 plus 2 here. Here we're going to have 14 minus 18. Either way, both sides equal negative 4. Everything checked out. We have a solution. All right, so just a little bit more because now we have a little simplifying to do. So 8x minus 18, there's not much more I can do there. But here, we need to distribute to get rid of these parentheses. We have 6 plus 8x minus 24. All right, now from here, we got to simplify a little bit more on the right-hand side because we have like terms. So we have 8x is equal to negative, if we remove the 6, negative 18. All right, so this is something you're going to start seeing later, but everything we've done is correct so far. Well, what am I going to do here? So if I add 18 to both sides, I get 8x is equal to 8x. But if I divide both sides by 8, I get x is equal to x. So sometimes we're going to see situations like this. So this is what you're going to see in the next video. This one basically saying that I could put anything in, it's going to work to have x equals x. X can be anything. Okay, so if we keep going with D now, so we have 3, 1 minus x equals 7 minus x minus 2. So we have to distribute. So we end up with 3 minus 3x equals 7. And here, remember there's like a negative 1 out front that's being distributed. So we get negative 1 times x, so negative x, negative 1 times negative 2, positive 2. And then if we simplify just a little further, 3 minus 3x, 7, oops, not 7, 7 plus 2 is 9, minus x. Okay. So let's say we add x to both sides to get the x's together. So now I have 3 minus 3x plus 2, so minus 2x. Here we're just left with 9. Subtract 3 from both sides so I can get 2x by itself. I have minus 2x is going to be equal to 6. And x should be equal to negative 3. Like I said, we should always check. So 3, 1 minus negative 3 equals 7 minus negative 3, negative 2. So this is a 3, 1 plus 3 equals 7 minus negative 5. So this is 7 plus 5. This side here is 3 times 4. This is 12. And this is 12. This checks out. Yes, I have the right solution. So I know this is one of the least favorite, but we got those decimals. So in this case, we only have a decimal that goes to a ones place in both cases. So we're going to multiply by not 100 because I just need 1, and I just need 1 0 after it because I only have one decimal place to worry about. So I'm going to do 10 times 5x minus 2.1, and then I'm going to have 10 times 8.4. So remember, just multiplying everything on both sides by 10. If I distribute this 10, I end up with 50x is equal to 50x minus 21 is equal to 84. Once again, this is something easier for us to handle. I can just add the 21 to both sides. So I'm going to end up with 105, and then we have 50x here. If we divide both sides by 50, you get up 105 divided by 50, which is going to be a 2.1. Like I said, these ones, it's easy to check by sticking it in the calculator. So 5 times 2.1 minus 2.1 equals 8.4. 5 times 2.1 is this a 10.5 minus 2.1. Sorry, my pad's a little crooked here. Equals 8.4. But does it? 10.5 minus 2.1 is 8.4. That checks. This is my solution. So don't always expect when you have decimals, you should have decimal solutions. Sometimes you won't. It's just in these cases we do. Sometimes you might end up with whole numbers. All right, so for f, we have 3 times, in parentheses, x minus 2, all that divided by 4, and then we have 5x divided by 6. So I need a number that is divisible by 4 and 6. You could have multiplied those together and got 24, but you could have looked and said, well, 12 works. This divides into 12 and gives us 2. 4 divides into 12 and gives us 3. So I just need a number that both those will divide into. And this is actually the smallest one. So that means I'm going to multiply both sides by 12. Like I said, if you use 24, 24 would have worked as well. I just need a number that divides in that 4 and 6 would divide into. Because we're trying to clear out that fraction, so we need something that's going to clear it, make it clear it, to clear it out for us. Sorry about that. So we have 12 times 3 times x minus 2, all divided by 4, equals 12 times 5x divided by 6. So what we see here is that we have 12 divided by 4. That leaves me with 3. I have 12 divided by 6. That leaves me with 2. So now I just have 3 times x minus 2 equals 2 times 5x. So here, you can do 3 times 3, so it's 9 times x minus 2 equals 10x. Then we can have 9x minus 18 equals 10x. We'll subtract 9x from both sides, leaving me with x is equal to negative 18. So it appears that our answer is x is equal to minus 18. Okay, just need to find a nice little place to check it here, so I'll try to fit it in here. So we want to check that 3 minus 18 minus 2 divided by 4. 5 times negative 18 divided by 6. So we're going to have 3 times negative 20 divided by 4 here. And then we're going to have, wrong calculator, 18 times 5. This is going to be negative 90 divided by 6. So this is negative 60 divided by 4. Negative 90 divided by 6 is negative 15. And negative 60 divided by 4 is also negative 15. So this worked out. That means, yes, this actually is the solution to F. All right, so what we're going to do here is we're going to move into more solving linear equations, but these ones have little catches like we saw in C.